Hello and welcome. I'm your host, Neil Howard. Thank you so much for joining us for another segment of Health Professional Radio. In this segment, we're going to be speaking with Dr. Jonathan Wall. He's joining us here from Attralus to talk about the latest developments in systemic amyloidosis research. Welcome to Health Professional Radio, Dr. Jonathan Wall. Thank you for joining us this morning.
Thank you very much. Great to be here.
Well, tell us about your professional background and your current role at Attralus.
So I'm a distinguished professor at the University of Tennessee Graduate School of Medicine at Knoxville, and I'm a co-founder of Attralus and the Interim Chief Scientific Officer and Advisor on amyloidosis. And I've spent 27 years working in the field of systemic amyloidosis, designing therapeutics and imaging agents for this unmet need for this disease.
So what exactly is systemic amyloidosis?
Yeah, it's a group of disorders that are characterized by the deposition of misfolded proteins that deposit outside the cells as protein fibrils, and they sequester proteins from the circulation and from the cells around which they deposit, and they form masses in these organs, masses of amyloid that cause disruption and dysfunction and eventually organ failure. And there are about 20 different forms of systemic amyloidosis. Some are hereditary, some are spontaneous. And there's a significant clinical unmet need with respect to diagnosing these patients early. It's often difficult to diagnose early and accurately. And there's also an unmet need in being able to remove these deposits and recover organ function.
Are the symptoms so subtle that people delay treatment or diagnosis? Why is it so difficult to diagnose? And once that diagnosis is made, what are the next steps?
So the diagnosis is difficult because the diseases are very heterogeneous in the way they present. So a lot of the symptoms look like other things that are far more common, and those are the things that get thought about first and evaluated first. And it's only when everything comes back negative for those disorders that people then start to think about amyloid. It is a rare disorder, and that makes it difficult. It's not in the front of the mind of the physicians who see these patients early on. So it often takes 2 to 3 years for these patients to go through their diagnostic journey. They see multiple physicians and specialists and multiple tests. The diagnosis is generally made by a histological evaluation of tissue from a biopsy, often subcutaneous fat or something that was taken at a colonoscopy, and it's stained with a specific dye called Congo red, and that dye can detect amyloid. And it's that point you get the first indication of amyloidosis. In some cases, there are some imaging abnormalities in echocardiography or in MRI analyses. And also there's a new test that's being applied called the pyrophosphate SPECT imaging system, and that allows physicians to detect amyloid in the heart of patients who have a specific form called transthyretin amyloidosis, or ATTR. Once the diagnosis is made, depending on the form of amyloid that you have, then the treatment paradigms sort of kick in, and most of these treatment paradigms right now are designed to inhibit further production of amyloid using various mechanisms.
When should someone expect symptoms to present? Teens, later in life, middle-aged?
It depends on the form of amyloidosis. Some are late stage, so later in life, 60, 70 years of age. Some of the hereditary forms, you can see symptoms occurring early teens, sort of mid-20s. These disorders, the hereditary ones in particular, can present very early on and be very, very hard to treat. And in those patients, these are very rare forms of amyloidosis. In those patients, it's very difficult to accurately detect unless you know that there's a genetic mutation that's causing the amyloidosis. And then a lot of these patients who have these rare forms, there's very little therapeutic interventions that can be made. But in general, the major forms of amyloidosis, ATTR and AL amyloidosis, occur later in life.
Understanding that it's rare, is there a population that is disproportionately affected?
Again, there are some mutation carriers. So these are people who have a mutation in a protein that could form amyloid. It doesn't always form amyloid in these people, but it can. So they have a predilection or a prevalence towards getting amyloidosis. So these patients can develop it, and so genetic mutations are important. I don't think there's any data out there that suggests that the environment or enough dietary factors can impact the deposition of amyloid. A lot of the problem we faced over the years is understanding who will get it and why they get it, and that's still something that a lot of people are still working on.
With so many forms of this rare disease, are there many different treatments for it?
In general, yes, but the underlying principles are basically the same. What you want to do, and the most successful historical treatments have been shutting off the precursor protein, so the protein that's about to form amyloid. And there are multiple ways to do that. In ATTR amyloidosis, there are genetic silencers that turn off the gene essentially and prevent the protein from being produced. There are also stabilizers for ATTR that actually hold the protein together and prevent it from forming amyloid deposits. In AL amyloidosis, which is light chain amyloidosis, the second most common form in the U.S., they attack the cell that makes the protein. So there's chemotherapy, immunotherapy, and protein degraders. So generally the idea is that you turn off the tap and prevent the protein from being produced, and that prevents the amyloid from building up. But the problem is these patients, when they get diagnosed, they have deposits, sufficient deposits in their organs that have caused dysfunction. And what we're not doing right now, what Attralus is aiming to do, is remove those deposits. Attralus is developing these disease-modifying reagents that can bind the amyloid in these organs and then get it cleared by the patient's immune system. And that's, the goal of what a lot of people are doing in Attralus in particular.
Now, I understand, that being said, that there was presentations at the International Symposium on Amyloidosis. Can you tell us about some of those findings that were announced at ISA and give us some insight into your recently initiated clinical trial of a compound for this disorder?
Yeah, so the International Society of Amyloidosis was held in Heidelberg in Germany this year, and Attralus presented quite a lot of data. Excitingly, we had presentations on the AT02 molecule. This is an antibody that's been functionalized with a small peptide that binds all forms of amyloid. It's a Pan-Amyloid removing Pan-Amyloid reactive reagent, so it works in all forms of amyloidosis. And the peptide directs this antibody to the amyloid in the tissues, and then that stimulates the immune system to remove the amyloid. And what we showed at the ISA was data that when amyloid has AT02 attached to it, then the cells that can take up the amyloid, macrophages, are enhanced. And so you get improved phagocytosis, uptake of the deposits by these cells, and that facilitates the removal. So we have two animal models that we presented, one for AL amyloidosis and another for a very aggressive form of systemic amyloid called AA. And we showed in that model that serial treatment with AT02 was able to hinder the progression of disease in these animals. So the amount of amyloid that built up in these organs was significantly reduced, and that translated to an improvement or a cessation of the organ dysfunction. So these organs functioned better because there was less amyloid in there. So we presented that data. There was also data on another pan-amyloid reactive molecule called AT04, which is a smaller version of AT02. And we're very excited about that because we think there's opportunities for it to penetrate the brain, the CNS, and work on amyloid diseases that are associated with the brain, particularly Alzheimer's disease, because what this molecule can do is bind two types of fibrils that form in the brains of patients with Alzheimer's disease, and we hope that will prevent their buildup and also facilitate their removal, and in AD patients, hopefully ameliorate the disease there as well.
What are the next steps for research?
So, as you mentioned, there's a phase 1 trial ongoing right now of AT02, and that's in healthy volunteers, and that was initiated a couple of years ago. It's a two-part study. Part 1 is a double-blinded, single-center, single-ascending dose in healthy volunteers. That's ongoing presently, and it's looking at safety and tolerability. And Part 2 will be an open-label study when we recruit AL patients and TTR patients with systemic amyloidosis, and we'll look at safety and tolerability in those patients as well. With AT04, we're excited because we're doing a lot of preclinical work on that CNS development and application for that small molecule and how effective that might be and how it would work in the brains of patients with Alzheimer's disease. And Attralus has also got an imaging agent, and AT01. We've been working on that and developing a novel variant of that that might meet a significant clinical unmet need and allow high throughput screening or screening of people who may have amyloidosis in a broader clinical setting. So there's lots going on in the research area.
Well, give us a website, if you would, where our listeners can learn more.
Yeah, so there's a lot more information on the Attralus website, and that's www.attralus.com, and there's information about all these reagents and how they work, and information about background and where we're going with it.
Jonathan, I appreciate your time this morning. Thank you so much for joining us here on Health Professional Radio.
Thank you, sir. Appreciate the opportunity.
You've been listening to Health Professional Radio. I'm your host, Neil Howard, in conversation with Dr. Jonathan Wall. Audio copies of this program are available at hpr.fm and healthprofessionalradio.com.au. You can also subscribe to the podcast on iTunes, listen in, download it, Anchor, Spotify, and be sure and subscribe to our YouTube channel at youtube.com/Health Professional Radio.